Hello viewers, myself Hasina Bibi, Assistant Professor of CSE Department, Rohini College of Engineering and Technology. In this video lecture, we are going to see one topic, probabilistic reasoning from the second unit. And the objectives are to understand about the probabilistic reasoning and to understand how to apply probability concepts in AI reasoning. Probabilistic reasoning. It is a way of knowledge representation. In AI systems, we need to represent the necessary knowledge. Then only the system can do its task. The system can solve problem or the system can do its assigned work. So the knowledge is very important for artificial intelligence systems. So probabilistic reasoning is one way of knowledge representation which will apply the concept of probability to indicate the uncertain knowledge. So in probabilistic reasoning, we combine the probability theory with logic to handle the uncertainty. It provides a way to handle the uncertainty that is the result of someone's laziness and ignorance. In real world, there are many scenarios where the certainty of the events is not confirmed, such as it will rain today, behavior of someone for some situations. We can't tell exactly what will happen in a match, like who will win. A match between two teams or two players, we can't tell about the result. So such scenarios, such situations are called uncertain situations. So this kind of informations are called uncertain informations. So these the AI with this kind of informations can be deal with probabilistic reasoning. So need of probabilistic reasoning in AI. When there are unpredictable outcomes, when specifications or possibilities of predicates becomes too large or to handle, when an unknown error occurs during an experiment. In probabilistic reasoning, there are two ways to solve problem with uncertain knowledge. We are going to see one rule, Bayes rule, otherwise called as Bayesian statistics. Before going to the Bayes rule, we can see some of the basic concepts of probability. Probability can be defined as a chance that an uncertain event will occur. It is the numerical value or numerical measure of the likelihood that an event will occur. The value of probability always remains between 0 and 1. Probability of A, P of A, indicates the probability of an event A. That is, what about the event A, whether it will happen, or what is the percentage level of the event. So this is called as probability of A. If P of A equal to 0 indicates total uncertainty in an event A. That is even not at all, no, never will happen. P of A equal to 1 means total certainty in an event, 100% the particular event will happen. We can find the probability of an uncertain event by using the below formula. Probability of occurrence equal to number of desired outcomes divided by total number of outcomes. So P of not A. We can also write this probability in a negation format. P of not A equal to probability of an event not happening event. And another one important formula is P of not A plus P of A equal to 1. And we are going to see about the conditional probability. So here we will compare two events. We will tell the probability of one event by comparing it with its related event. So conditional probability is the probability of occurring an event when another event has already happened. Let us suppose we want to calculate the event A when event B has already occurred. The probability of A under the conditions of B. It can be written as P of A on B. That is, if B is true, if B have happened, what about the probability of A? So we should understand A and B are related events. Both have some dependency. If B happened, what about the probability value of A? That is called as conditional probability of A on B. We can use the formula is equal to P of A and B divided by P of B. A and B is joint probability of A and B. That is the possibility of happening A and B together. That is P of A and B divided by P of B. And P of B is called as marginal probability of B. Okay. So if the probability of A is given and we need to find out the probability of B, then it will be given as P of B on A equal to P of A and B divided by P of A. We can see one problem. In class there are 70% of students who like English and 40% of the students like English and mathematics. Then what is the percentage of students? Those who like English also like mathematics. So let us use two variables A and B for this scenario. A is an event that is students like mathematics. B is an event that is students like English. So we want to calculate the percentage of students, those who like English also like mathematics. So it can be written as P of A on B. So B is an event that student like English. If the student P of A on B represent the students those like English, what about the probability of such students like mathematics? P of A on B is equal to P of A and B, that is the students those like both English and maths divided by P of B, which is equal to, already we have the value for P of A and B, that is 40%. The students those like both English and maths. 40% means in probability we can write 0.4. And P of B we know the value, that is the students who likes English. So in probability we can write it as 0.7. So we are getting the value 57%. So 57% is the value answer for 57% of the students who like English also likes mathematics. Now Bayesian reasoning. So the probability reasoning with the Bayes theorem is called as Bayesian reasoning, which is also determines the probability of an event with uncertain knowledge. It relates the conditional probability and marginal probability. So we know the conditional probability. So we can apply the Bayesian inference for some problems. If cancer corresponds to one age, then by using Bayes theorem we can determine the probability of cancer more accurately with the help of the attribute age. Bayes theorem can be derived using the product rule and conditional probability of event A with known event B. And there is a formula, P of A and B is equal to, from the previous formula, that is the formula of conditional probability, we can rewrite the formula P of A and B equal to P of A on B into P of B. Similarly, the probability of event B with known event A can be written as P of A and B is equal to P of B on A into P of A. Equating the right hand sides of both equations, we are getting P of A on B is equal to P of A on B, that is the conditional probability of A on B is equal to P of B on A into P of A divided by P of B. This formula is called as Bayes rule, where P of A on B is called as posterior probability. P of B on A, the right hand side value P of B on A is called as likelihood, in which we consider the hypothesis is true. Then we calculate the probability of evidence. Then P of A is called as prior probability, P of B is called as marginal probability. So we can also have the formula for if you consider a sequence of events AI, that is A1, if we are going to deal with the sequence of events A1, A2, A3 up to AN, that is set of mutually exclusive or exhaustive events. Also we are having the formula to identify the probability levels of this set of events. And in some applications we will analyze the cause and effect with the probability concept. So P of cause on effect. Effect means it may be some symptoms. It may be some hypothesis. Cause means it may be some symptoms. So P of cause on effect equal to the same concept, the same formula, P of effect on cause into P of cause divided by P of effect. And we can see another one example. What is the probability that a patient has disease meningitis with a stiff neck? The meaning is stiff neck is maybe one of the symptoms of the particular disease meningitis. So we want to calculate the probability of the patients having the stiff neck if they have the disease meningitis. Okay. So the given data, a doctor is telling about some statistics, that is meningitis causes the patient to have a stiff neck and it occurs 80% of the time. That is 80% of the patients, those who are having the meningitis, will also have the stiff neck. So the known probability that and another one common strategy is statistic is the probability that a patient has meningitis disease is 1 out of 30,000 patients. That is 1 out of 30,000 patients will have this particular disease. And the known probability that a patient has a stiff neck is 2%. On the whole, 2% of patients may have this symptom, stiff neck. And our problem is, what is the probability that a patient has disease meningitis with a stiff neck? So let A be the proportion that the patient has stiff neck and B be the proportion that the patient has meningitis. So we can calculate the probability value. Already we can have some values, that is 80% of the patients, those who are having the meningitis, will also have the stiff neck. So we can write this as P of A on B, that is B is stiff neck, A is meningitis disease. So A on B means if the patient is having meningitis, what about the probability that a particular patient is having stiff neck? That is 80%, 0.8. P of B, this is the probability of having the disease. That is 1 out of 30,000 patients. One patient out of 30,000 patients having this disease. P of A is equal to 0.02. That is, on the whole, 2% of the patients are having the stiff neck. And from the given data, we can apply the given data into the formula. P of B on A is equal to P of A on B into P of B divided by P of A. So when we apply the values, we are getting 0.00133. That is, so when we change the values into some value, some proportion, we are getting 1 patient out of 750 patients has meningitis disease with a stiff neck. So in this way, we can, with the help of Bayesian Bayes rule, we can calculate the some probabilistic values, and which is used in the reasoning of AI. And we can see the applications of Bayes theorem in artificial intelligence. It is used to calculate the next step of the robot when the already executed step is given. Bayes theorem is helpful in weather forecasting. It can solve the Monty Hall problem. Thank you.